formats and formats for HDRI and in the linear workflow. And I have to tell you, that is quite a simple theme. If you use just linearized material for the input and linearized material for the output, then you have no problems with anything in Cinema 4D, because everything here is pretty much optimized for this workflow. The trouble starts if you use maybe JPEG with a baked-in gamma and camera response curve, because Cinema 4D can read out the color profile, but it can't hear what the camera has done to the values, the tonal or the camera response curve. And there pretty much the trouble starts. So if you want to get safe, no JPEGs. It's that simple. Anything 8-bit can be affected in many ways just to get the data into these 8 small bits. And so my best advice is go to the project settings, stay in linear workflow, and don't use sRGB. Of course, there are many flavors of sRGB. Even there is a linear version of it available, but the gamut, the way or the large field of colors that can be used, is pretty much the smallest available. Even if Rec 709 is pretty much similar to that, which brings us to the theme of video. Video has mostly baked in gamma, and that's not really fun, and you have to take care of that as well. So in the moment something has an sRGB on it, I would take really precautions if you get good material, or if someone has screwed it up and distorted the whole thing. Maybe even brought back some highlights to really mess up the data that you finally have. Or the worst case happen, someone gives you tone mapped images for the background or something like that. Then you have to react to the background to fit everything. The objects in the foreground has to match this, the light has to match it, and that's pretty much one of my main themes that you will see I will discuss a little bit more. When you bring in non-quality or low quality, you have to adapt exactly this level. There is no fixing in post. Of course, there will be always a little trick, a little something that you can do, but the rule of thumb is the minutes that you save in pre-production cost you 10 minutes or an hour in production, and at least 10 hours or up to 100 hours in post-production, based on the mess that was created. And so what you can heal before you even start, don't try even to do it then to fix it in post. So JPEG and all these stuff where baked in gamma is available with camera or tonal response curves baked in as well. Put your hands away from it. Do yourself a favor, work with quality. Which brings us to the next point. What can we use here finally? Of course, most of the formats that we can also write out. So I have my focus here now on this panel, Save. And here we have some surprises in it. And when we take a look, for example, DPX, this is normally a derivation or the more modern format of Cineon, to say it sloppily. It's normally based on log file, but also available in a linear version. You can spot this pretty easily when you go here to options. There's no way to say where to set the black or the white point in it, which is normally 1995 or 685 and so on. Not available, so you don't have here the logarithmic file of it, and so it's not a really common file format. I wouldn't use it, to be honest, and I never have done it. Then we have here a wide variety of options, and I go here maybe to TIFF first. TIFF in 32-bit here in Cinema 4D has no options, so you can't really set up the compression methods. You end up in 32-bit with really huge files. It's a very stable format. Many people can read it, or many applications can read it, to say it precisely. It's a workhorse, but it takes a lot of space. The next one would be then here, Photoshop 32-bit works fine. But of course, also here you get huge files and no way to change anything in terms of compression methods. And you can have linear color space. Works fine. I have it more than often in my image work, but again, huge files. And when you have huge files, you have to use the photo large document files, which means everything below 2 GB is Photoshop, PSD, and everything above 2 GB is PSB, which I have more than often for my panoramas, which goes up to 6 or 7 GB per image. So when you have those monsters open in 32-bit, that's quite something to digest for the computer. And which brings us then to OpenEXR. And you see here 2 versions of it. My advice, don't even bother to use QuickTime OpenEXR. It's not a preferred suggestion for me. As long as you can go here to OpenEXR, use it. And you have here different options for compression. If you really want to compress it, use something lossless. Don't go here to lossy stuff. I wouldn't really bother with this, but it's up to you and the space that you can afford on your hard drive. OpenEXR, industry standard, well proven at ILM, Digital Domain, and many other big studios. So don't even think there is something wrong with it. It's a format that I always use when I want to have a precise workflow with relatively small files. Then we have something here in where I get always a little bit in anger. And that is Radiance HDR. And the file by itself is a genius idea, I have to admit, but it's 20 years old and it has to go. From my point of view, it's end of life. It was 20 years ago a clever idea. And I want to tell you, of course, what's wrong with it and how it is done. And many people love this format because they got it just wrong. Now we will say, he tells us fairy tales. Okay, let's have a look here to the picture viewer. And in the picture viewer, I have here one picture where I just used in Photoshop the standard rainbow, just a gradient. It goes not even over 100% in any channel. And then I multiplied it several times to get a multiplication of 0.001. And then I saved it. And then I open it again and took it multiplied by 1000. And to make exactly the damage visible that we have in a file, I put a levels on top of that to make that visible and took the levels then from 0 to 24 instead of 0 to 100. The OpenEXR file has nearly no problem here. And I made this visible by using the original file on top of it and used the difference. The OpenEXR file has naturally below 1% of mistakes in these cases. Okay, I had a long discussion with some people about this value, 1000, or divided by 1000 to name this in the right way. That sounds a lot, but to be honest, it's an ND filter 3.0, something that I use on my Red Scarlet more than often, and sometimes I use even more when I have maybe in need to use an f-stop of 22, but I want to work with an f-stop of 8. Then I have already way over 10 stops, and an ND filter, neutral density filter of 3.0, pulls it down to roughly 10 stops. And ND 3.0 is exactly 1000. And as I said, 22 to 8 is 14 stops, so it would be here exactly way more. Nothing serious finally that I have done here. But some people will argue 1000 is something that you never do. Of course not. So what I have done here is, of course, to find out that these values here are not really working very well with the HDR Radiance format. And that has a reason. We get bending like hell here. And you will read in every second book about HDRI that HDR Radiance is a 32-bit format. Let's have a look. I want to explain, of course, the Radiance format and how it works. It is by default an RGBE format. So what is that? What is the E for? It's a 4-channel format. First of all, everyone tells you it's a 32-bit format, but it's per pixel. That's the big difference. It's not 32-bit per channel. In that way, we have to deal here with a picture that has 4 channels, and each channel has only 8 bits. In the time when it was created, it was a genius idea, and there's nothing wrong with it at that time to use it. But a few years later already, the developer itself started to develop something else. And parallel to that, OpenEXR was developed because of the shortcomings of that. This format here is, as before, the only format that can store values that go beyond the illumination of the sun. But who needs that? And there, exactly in this wide dynamic, is the shortcoming. How does it work? Okay, we have R, G, and B as normal 8-bit picture files. And then we have here E for exponent, as I would translate it, and this takes 3 values, R, G, and B, at the same time as one color and takes it times the XE value. And so we have not the differentiation that we have with OpenEXR, where each file can have that wide variety of 32-bit per channel. Now here we talk about, with RGBE, 8-bit per channel. So we create an 8-bit picture finally, and then divide or multiply it with this here. And that means it is a wonderful format if we are very interested in the light intensity, but for color, that's something doesn't work very well. So for illumination it might work, but the colors that you produce are maybe not precise. And when you take a look, if you can create only with this package here a color and then go up to the sun in terms of illumination and beyond, and then back again, something will suffer here. And the 32-bit per pixel is exactly how a print office would express the values. But we are in the visual effect industry, or in 3D, in animation, we talk about channels here. And so 8-bit per channel is the right thing. It's in floating point format finally, so there is some advantage in it. But the error value is at least double as high as in the OpenEXR file. OpenEXR has, by default, when we use it per standard, for each 32-bit, 32-bit, 32-bit per channel each time, and independent. So the blue can go up to the sky, and R and G could be very small, which is not possible with this one here. And again, when I go here back to this, I haven't even started to use any values beyond 100% in the classical way. So if you want to do yourself a favor, the radiance format is end of life from my point of view. And when you think about the 8-bit per channel times 4, that explains why the file is always smaller than anything else, because it contains nearly no information. Again, it was a genius idea, and it has done its work. Goodbye. Okay, back to Cinema 4D and all the other file formats here. So after this long, moody explanation about the radiance and the fantastic OpenEXR file, I have to tell, I have really tried to have a change here in the 32-bit per channel for the radiance. No one is really listening, but you can read it exactly from the developer of this format, that this is not a 32-bit per channel format. So this is a bug here, I have to tell it, but no one changes obviously, so we have to live with it. Okay, multipass. When we take a look now to multipass, then we can see which format here finally gives me multi-layer. Radiance, for example, doesn't do this. It's grayed out. But we can have this here in Photoshop. It's on. But the problem with Photoshop and multi-layered files is that even After Effects can't read alpha channels, multi-layered, and the image layers at the same time. You get only one alpha channel at the moment to be read out, even if I switch this on. So all the objects buffer, etc. will not show up in After Effects. So don't use Photoshop, even if it is a very clean format for that, with some concerns from my side. TIFF works in the same way. It can contain everything, even multi-layered, but don't use it when you want to go with After Effects, for example. Doesn't work very well. And then we go with OpenEXR. And there I would suggest OpenEXR is the native file for digital domains, or the Foundry's Nuke. And there you can have access to all these files. I will talk about this in another series, not here and not now. So we can see we have here an option to decide already what works for us. And let's have a look. DPX doesn't work with multi-files, and BMP has not even 32-bit. And we can go here alone, and maybe some changes will happen in the future. But I think I made my point clear. There is only one winner really in terms of file size, precision, and usability in many compositing applications. From my point of view, this is the format of the future. It works nicely inside of Cinema 4D. And I hope we will see more features enabled, because this format can contain a lot of stuff more than just this here. Okay, thanks for listening. See you in the next part.